Congratulations, guys! At this point in the semester, you've completed all the new material, and the only thing left is to review everything you've learned in preparation for your benchmark quiz the last week of school. We'll review one chapter a day. Today we are reviewing Chapter 6, the chapter about properties of polygons, quadrilaterals, and parallelograms. When it comes to polygons of all kinds, there's three theorems you want to keep in your memory. The first is called the polygon interior angle sum theorem. This is that one that says if you want to know what the sum of all the interior angles should add up to, it will always be the same thing as quantity n minus 2 times 180, where n is the number of sides or the number of angles your shape has. Quick example to refresh your memory. If you look at the example below, if you count the sides, there are 1, 2, 3, 4, 5, 6 sides, meaning there'd be 6 angles as well, because the number of sides and angles are always the same with polygons. So n equals 6. So to solve for the missing angle here, we could use the fact that the 6 angles should all add up to 720 because of the sum of interior angles rule, n minus 2 times 180. We can then say, well, if I add up the angles I do know, the 90, the 124, the 150, 93, 130, and x, the unknown angle, it should equal that sum of 720. We can then simplify that expression by squishing the like terms together and solve for x by subtracting 587 from both sides of the equal sign. X equals 133 degrees. So the first theorem we reviewed was about finding the sum, or the total, of all the angles added up, and the equation for that is n minus 2 times 180. However, if we have a regular polygon where all the sides and angles are equivalent to each other, and we want to know only one of those angles, you take that equation and you divide by n to split the total equally between the n angles. Let's work through an example together. So if you look at this figure, count the sides to figure out n. N equals 5. So if we want to know what only one of those interior angles has a measure of, we would plug that into the formula above. Replace both those n's with 5's. And simplify from there. We should get 108 degrees for one angle in the regular polygon. Keep in mind, this process only works if you know it's a regular polygon where all the angles will be equal to each other. For a polygon like the one in the old equation, it would not have helped because all the angles had different sizes anyway. So both of the first two theorems were about interior angles, angles on the inside of your polygon. The last rule is about exterior angles, angles that you create when you extend one side of the polygon and look outside the polygon itself. The exterior angle sum theorem says that no matter what n is, no matter how many sides your polygon has, the sum of all the exterior angles together will always equal 360 degrees. So this theorem has a lot of uses. When it comes to solving for exterior angles, one potential use is to solve for a single exterior angle in a regular polygon. Here we have a regular polygon with 7 sides. So we could use the fact that if we drew all the exterior angles, there'd be 7 of them, to split the total of 360 equally 7 ways. So one exterior angle would be about 51.4 degrees. Now, quick note, the 360 will only be split equally if it's a regular polygon. If all the angles are different sizes, though, like in any polygon that's not regular, then we could say if we add up all the exterior angles, it could equal 360. Another quick note about solving for exterior angles, which doesn't really have much to do with this 360 rule, but it's important, is that you can also solve for an exterior angle if you know the interior angle next to it. For example, backtracking to the picture in our first example, I could figure out that if I extended this side, the exterior angle would be 50 degrees, because I could just do 180 minus 30. I can say that an exterior angle here would make a linear pair with an interior angle here. So make this note to yourself. If it's not a regular polygon, remember that it still adds up with the interior angle it's next to equal 180 degrees, since it's making a straight line with that angle. And that will help as well. So the first part of chapter 6 was about polygons in general, and then you remember how the last roughly 2/3 of the chapter focused on quadrilaterals, polygons with 4 sides. Let's talk about the different quadrilaterals we went over in that part of the chapter. So one thing I would recommend you do with this chart is I would recommend you add a quick sketch of each shape next to the box where it's described, because that'll make it easier for you when you're working on the practice problems on the next page to hunt down the shapes that you need to review. For example, if you have a problem that looks like a kite in the practice on the next page, then you might want to find the kite box and read through the rules about kites really quick to help you solve it. For example, the fact that a trapezoid is defined as a quadrilateral with one pair of parallel sides, like here and here, might help you solve for missing angles here. Sometimes they'll tell you one and ask for the other. Because these are parallel sides, these would be same side interior angles and add up to 180 degrees. All right, that's it for today's notes. Now continue working on the rest of the packet. Good luck.